Hi, my name is Will Lehman, and I'm here to present on a comparison between HEC-FDA and WAT regarding the watershed systems approach for the FDA prospect course. Here I have a simplified schematic of an HEC-FDA model. As you can see, there are 4 damage reaches. Each of those damage reaches are modeled with the same basic relationships of flow probability, flow stage, and stage damage. Now, those relationships are in the compute of damages are actually going to be sampled independent of one another. Each reach is independent. That means that if we had levees in the system, if a levee were to breach in an upper reach, like reach 4, it would have no impact on the stage frequency of damage reach 1 or damage reach 2. If a dam were to breach in reach 3, it would have no impact on reach 4, or reach 2, or reach 1. So those relationships are not interdependent. They're not creating a system response for the entire system. However, in HEC-WAT, what we do is we actually model that explicitly. We do that by having system-wide models, like the system-wide HEC-HMS model for rainfall runoff, a system-wide ResSim model for reservoir operations. We might have a fragility curve sampler that happens before ResSim that samples when the dams are going to breach. That gives us the ability to change the system operation in ResSim so that if a dam was breached, that the other dams would compensate to control more flow to meet downstream objectives, however that's possible with the system. And then HEC-RAS would run to model any of the hydraulic problems that occur, whether that's a dam failure event or whether that's just the joining of two events that happen downstream of the dams. So in WAT, we're modeling this for each event, and we're modeling it explicitly. Once we have that downstream watershed-based depth grid, then we can actually compute consequences, and we will get the consequences for that particular event. And that happens in that Monte Carlo, like we've been talking about. Here's an example of why it's important to have a system-based response. When these dams break, they turn red, and then you can see the water flowing down. So the conditions associated with each of the dam breaches is dependent upon the conditions provided by the previous dam breach, and the system behaves as a whole. That affects backwater, that affects downstream stages, it affects every aspect of the model. So we need to respect that within our modeling domain so that we can understand the nature of the hydraulic event in situ when we're computing consequences.